Welcome everyone. So in today's video, we are going to discuss the solution of a very interesting mathematics problem. So here we have to find the value of infinity factorial divided by infinity raised to infinity. So in order to find the value of this expression, we will first convert this question into a limit. That is, what will be the value of limit x tending towards infinity x factorial divided by x raised to x. So here, very first, x is a very large positive quantity. That means here x will be greater than 0. And if x is greater than 0, that means x factorial divided by x raised to x will also be greater than 0. So consider it as inequality I1. So further, the x factorial can be written as 1 multiplied 2 multiplied 3 up to x. Similarly, x raised to x can be written as x multiplied x up to x. So here, the ratio of these two quantities, x factorial divided by x raised to x, will be like 1 multiplied 2 multiplied 3 up to x divided by x multiplied x up to x. So if we rearrange this ratio, so the resultant will be like 1 divided by x multiplied 2 divided by x multiplied 3 divided by x up to x divided by x. So here the ratio x divided by x will exactly be 1, and before that we may have x minus 1 divided by x, that will be less than 1. Similarly, but before that, we also had a term like x minus 2 divided by x, that will also be less than 1. Similarly, 1 by x will also be less than 1 since x is a very large positive quantity. If all these quantities are less than 1, if you multiply two or more quantities, those lies between 0 and 1, so the multiplication becomes very smaller. In fact, the multiplication will always be less than 1. That means if we multiplied 2 divided by x multiplied by 3 divided by x multiplied 4 divided by x up to multiplied x divided by x. So the product of these quantities will always be less than 1. That means the quantity 1 divided by x multiplied 2 divided by x multiplied 3 divided by x up to multiplied x divided by x will be less than 1 divided by x. That means the quantity x factorial divided by x raised to x will be less than 1 divided by x, and consider it as inequality I2. So if we compare inequality I1 and inequality I2, that means we will have x factorial divided by x raised to x, that lies between 0 and 1 divided by x. So further, if we use the sandwich theorem here and apply limit x tending towards infinity in this inequality I, so the final result will be limit x tending towards infinity of 0 less than limit x tending towards infinity x factorial divided by x raised to x, which is less than limit x tending towards infinity 1 divided by x. This is constant, so the resultant will be 0, which is less than, and this is nothing but infinity factorial divided by infinity raised to infinity, that will be less than. If x tending towards infinity, then 1 upon x tending towards 0, that means it will also tending towards 0. So with the help of sandwich theorem, here we can say that the value of infinity factorial divided by infinity raised to infinity will tending towards 0. Or we can further write it as infinity divided by infinity raised to infinity is equal to 0. In fact, in practice of limit always gives us the tending values, but in practice we always write it as an absolute value. For example, if we have to find the value of limit x tending towards 2 divided by x, that means when x tending towards 2, that means 2 by x will tending towards 1. But in practice we always write the answer of such questions, that is limit x tending towards 2 divided by x is equal to 1. So with such practice, we can conclude that the value of infinity factorial divided by infinity raised to infinity will be equal to 0. But it must be tending value. That means the answer must be like the value of infinity factorial divided by infinity raised to infinity must tending towards 0. That is very close to 0. So it can be called it as 0. So this is from my side, and hope you would definitely enjoy the solution and the manner we discuss it. So please don't forget to like, share, and subscribe to the channel. Thanks a lot.